Hello friends, welcome to our channel. In my previous lecture I have discussed how to find out the fixed end moment of a fixed beam having a concentrated load at the middle point. Okay, I have discussed that in case of the point A, here anti-clockwise moment will develop, and at the right side of the beam clockwise moment will develop, and the value will be plus PL by 8 and it will be minus PL by 8. And I told that clockwise moment is always positive and anti-clockwise moment is always negative. Okay, and I solved this problem and I told how to find out the fixed end moment. Okay, so first of all I split this beam into two parts. Okay, two parts is a part 1 and the part 2. Okay, in this part 1 it's simply supported beam having a point load at the mid span, and for this point load it will produce a sagging moment. Beam will bend in this way. That's why the bending moment diagram for the part 1 will be a triangular. Okay, triangular, and its value is PL by 4, and all of you know that's why I am not calculating this. And for this the bending moment diagram will be rectangular, and this value is the fixed end moment. FEM AB and FEM BA will be equal because load is symmetric. Okay, it is not unsymmetrical load, that is symmetric loading. That's why the moment, a fixed end moment producing at the point B as well as point A will be same. So it is the bending moment diagram for the part 2. Okay, now I have to add these two bending area of this two bending moment diagram, and I have to equate this equal to 0, because actual case in beam there is no bending is happen, because no bending is happen, and how much bending is happen, it will be very negligible. That means we can write it as 0. Okay, that's why the area of this triangle plus area of this triangle will be equal to 0, and so we can equate these two, and from this we can find out the value of the value of the fixed end moment PL by 8. Okay, now I have discussed about some special cases for fixed end moment, so I will not discuss how to find out, because I have already told in this in my previous lecture how to find out, and I am telling you in this lecture how to find out the fixed end moment. So just I am telling you the special cases. Okay, let's see. Now suppose it's a fixed beam, having UDL W kilonewton per meter. Okay, point A, point B. Now what will be the fixed end moment? FEM AB and FEM BA. What will be the value? FEM fixed end moment from A to B, and it is the B to A. Okay, so the value will be, here it will be negative moment, it will be a positive moment. The value will be WL square by 12. It will be plus WL square by 12, and it will be minus WL square by 12, minus WL square by 12. Okay, so it is a case 1. Now second case, suppose it's a fixed beam having a concentrated load P, but load is not symmetrical. Suppose the total length of this beam is L, and it's acting point A, point B. It's acting from point A, and acting from B at a B distance. Okay, so what will be the value of the fixed end moment in this case? In this case, value of the fixed end moment will be, here it will be P A B square by L square with negative sign. Okay, and here it will be P B A square by L square with positive sign. Okay, mind it always, it is clockwise moment and it's an anti-clockwise moment. It is the case 1, this is the case 2. Now another case, support sinking cases. Suppose it's a beam, it's the original beam. Okay, so it's also a fixed beam, but if this support sinks by amount of delta is the previous position and it is the final position and it is the delta. So what will be the fixed end moment of this case? Okay, it will produce a anti-clockwise moment here, also it will produce anti-clockwise moment here, and this fixed end value will be, fixed end moment will be minus 6 EI delta by L square. Okay, and it will also be minus 6 EI delta by L square. Okay, these two are negative because these are the anti-clockwise moments. It is the number 3 cases. Now number 4 case, suppose it's a fixed beam and a concentrated moment is acting here, this is the m naught. So what will be the value of the fixed end moment? So here moment will be clockwise, so the value will be positive, and total, suppose it's acting at a distance A from A and it's B from B. Okay, so what will be the value of this fixed end moment? FEM AB, FEM AB equals to m naught B 3A minus L divided by L square. Okay, and FEM BA will be m naught A to 3B minus L by L square. Okay, it is a fixed end, it is a number 4 cases. Okay, now case number 5, suppose it's a fixed beam and having say UVL. Okay, now this is the also another case, the case number 5. So it is the fixed beam having UVL, uniformly varying load, UVL. Okay, here intensity is the W and here it is, here its intensity is 0. So what will be the fixed end moment? So in this case value of the fixed end moment will be, here it is negative and its value will be minus WL square by 13, minus W square by, sorry, it will be 20, and here it will be plus WL square by 30. Okay guys, so these are the some special cases for fixed end moment, which is very useful for a moment distribution method or slope deflection method, or also any other method. This fixed end moment is also needed. Okay, so thank you guys for watching this video.